name's Ryan, and today we're going to be taking a look at some coursework I did in the second semester of my first year at uni. So for this module we were looking at algorithms, data structures and maths. Part of the module contained a 30% test. This included maths and also a coding aspect, which I achieved 69% on, I believe. So we also had a 70% piece of coursework to hand in. This was to create a converter. So this program had to read in a text file that was given to us, and so we had to find a way to read this into the program that we created, and then allow the program to take the units inside of those inside of that text document and use those to be able to convert between them. So if we quickly take a look at the text file that we were given, we can see that we have ounce and gram, and so there are 28 grams in an ounce, so we get a conversion that way. Obviously the same with ounces in pounds, as 16, 0.454 kilograms in a pound, and then so on and so forth. We also had to account for capital letters in those, so as we can see there's a capital I there, which doesn't really make too much sense when the rest of it is lowercase. And also the user's input might also be different, so we had to make sure that we were considerate of that as well. Make it, if they typed in a capital I, we would then have to put that into lowercase. That was sort of the higher stretch mark, kind of making your own algorithm sort of bits there, which I believe I managed to get to as well. So if we take a quick look at the code, we can see that we have a or a loop rather, that while the user wants to exit is false, it will continue to loop the program. And we can see down the bottom that during a certain event that the user wants to exit equals true, and it will come out of that loop. If we scroll all the way back to the top, so we read in the file using a stream reader with obviously the file which is inside of this variable here. I then set the count to 0, so I can count the amount of lines within the document. And while it's first of all, I set a bool isEnd equals false, and while isEnd is false, it will continue to read lines. The stream reader, that is, will continue to read lines, and as it reads each line, it will count. It will add 1 to count. And once it gets to the end of the stream, it changes end to true, and then afterwards close the stream reader. I then use the number in count to create a string array called full line here, to initialize the amount of spaces I need, or lines rather, that I need to hold all of the data to start off with. I then initialize the second stream reader, and read in all of the file into each array space. So for index 0, the first line would be popped into that one, and so on and so forth. So the second line to the first index, which is essentially the second. After that, I then again close the stream reader, so it's not draining any resources there when it doesn't need to be. Then initialize null count. Obviously realize all of these, all of the variables I'm initializing here could easily have been popped at the top to make it a bit more tidy. Unfortunately, I didn't get enough time. I think I only just managed to scrape in a couple of the algorithms that I wanted to get in there. But again, it comes down to planning and preparation really. If I would have planned for a bit more extra time at the end to sort of fiddle with some things and mix, sort of focus on what I needed to do to get an overall higher mark. Could have easily have done that amongst a few other things as well. Like instead of a string array, I could easily have used a list. Um, but again, I didn't quite have time to implement that. So I'll carry on with the code here. We'll go through each line, reading it, and seeing if it's null. So if the full line I, obviously whichever one, which getting a bit stuck here. So it goes into a for loop, counts through each line that's in the count array. Is it the count array? The full line array. So obviously here, if full line I, so for index 0, it will read that line first, look at what the string is inside of that one, and then determine whether it's empty or not. And if it is empty, I'll make it equal null, which then allows me to put null count up by 1. So I have a count of how many null lines I have, which again, if we go back to the text file that we received, we did get a completely empty line, and this wouldn't really be sort of wasted space. If we had a much larger conversion document to read in, we could quickly drain some resources there and just go through extra steps that it doesn't need to do. So if we're carrying on here, got a nice little output there. Here are the results of the text file, shows you everything you need to know. And yeah, then then it goes through the array, writes each line out so you can actually see what the results are. Then I initialize word count, and oh yeah, this gets a bit complicated here. So I create another string array called converted this time, and I take the count so far minus the null count and times this by 3. And so the idea there is each line has three parts to it. So if we take a quick look back again, we've got 3 parts, which is ounce, gram, and the number 28. So my plan was to separate each word out of each line and put it into the new array, and this is done by splitting by each comma down here, making sure to filter out anything that any line that equals null. Obviously just stops it trying to split by what it can't split because there's nothing there. Pretty straightforward. This is inside of 2 for loops as well, I believe, or 3 for loops it goes through. So the first one is obviously just looking at each line and determining whether it's null or not, and then carrying on if it isn't null, otherwise just going to the next line if it is. And once we go into the second one, we see that I initialize a new text value to an empty string, and go into the third one, which splits, I believe, by each letter, splits the string I've just popped into conversions. Is it conversions J? I just popped it into. Yep, yeah. So it just goes into conversions, and so conversions J. So for the first index, it would be conversion 0 dot length, gets the length of that word, and then I have a character replace, or a char variable called replace one with a space, basically. The text value that I initialized here, there's so many initialized values, I can't believe how messy this is. I make that equal to whatever conversions J was. Then I check the int value of char for each different character in the text. That's obviously why we've got the third loop, to check each character within each word. And I believe if there are any spaces, yeah, it makes them not spaces, just makes it an empty value, and that filters out all of the spaces. I then go through, if text k equals replace one, do nothing. So then that is, if it's already a space, do nothing to this. Um, Else, if it's a value between 90, 91? Yeah, if it's the value between 91 and 64, no, 90 and 65 actually, that means it's a capital letter, I believe. And so I just add 32 to the int value of each character, and that makes it non-capital, so lowercase. It gets rid of all the capitals, so that's really useful. I did this off my own back as well. We weren't taught how to convert um, uppercase to lowercase or vice versa. Um, I'm not sure if there is actually another way to do it quite yet, but it was just a quick little bit of research on the MSDN Microsoft sort of forums that they've got going on, and quite easily found out how to do it just by obviously adding 32 or minusing if I wanted to do it the other way around. We then also have the new char that I created adds in the int value of what we've just done. That makes, yeah, I add that into the new text, which essentially reassembles the word that we had to begin with. So we can have the new word with all the lowercase, no spaces, all that sort of lovely stuff, and not the one that we didn't want to begin with. Else, if we don't want to do any of that, the new text just equals, or the new text adds in the character that didn't need to check for any of these. And after we've finished the loop on the word, we add. Is that correct? The value of the converted index determined by the value of word count is set to the value of new text. Running a bit slow here, sorry. So we essentially come out with the new line that we wanted. Then the next bit was again a bit complicated. Had to reassemble what I had basically disassembled each line. I believe this is what I was trying to do. Add index of string 1's value. Yeah, so essentially I'm just reconnecting each line back together, and it's already trimmed out all of the, all of the capitals, all of the spaces, all of the null lines, so we no longer have any of that. So we make the for loop count minus null count, so we have only the lines that we need. Obviously, there are actually no null lines in the converted array, and so we don't have to filter those out. All we have to do is initialize the for loop to not need so many spaces, because we've already taken out all of the null lines. And so with the new line, we take converted string 1 plus 3 times I, so this will be 0 plus 3 times I, which to begin with is 0, so we take index 1, or index 0 rather, because 0 plus 0 is 0. We then take converted string 2, which is 1 plus 3 times I, which again is only 1, and then we get 2 plus 3 times I again is 0, so 2 plus 0 is 2. We get index 0, 1 and 2. Again, this works no matter how many lines you originally started with. If we go for the next lot of values, we get 0 plus 3, which is 3, so we get the third index, or the fourth index rather, but yeah, and then we get the fourth and fifth. Put those together, we've got the full second line again, and continue going if we need to. After we've done that, we set the actual array space to new line, so that we've got it stored in the array. And then we ask the user to enter the unit of measurement that they want to convert. And for some reason, I decided to ask the user to exclude any S's in the inside of the input that they put into the computer, into the program, to say what they want. I could have easily worked a way around this, seeing if the last character was an S just by the int value, or if it even equaled just S. I could easily have just not put it in. I'm guessing I must have run out of time, as that wasn't implemented, unfortunately. Would have made it a little bit better, allowing the user a bit more freedom while not really draining any resources there. So we get, obviously, the user's input from the string that they put into the obviously the text they put in, and we initialize new text 1, and then we start a loop to change user input 1 to all lowercases and get rid of any spaces. Again, this is just the same sort of algorithm that was above here, where we just filtered out all the spaces and uppercases, just to sort of, obviously we need the correct unit of measurement to go back to the sheet, obviously all the stuff that's stored in the new array we just created, and check what we're actually trying to convert, and whether it's actually there later on. We'll see, we check against all of it, and obviously if it's not there, it's not going to be able to convert between them, and if it is, we can find out what it is and how we're going to deal with it. So we get the new text 2, which is again just the same thing as the new text 1. That is the measurement of the unit of measurement, sorry, that they wish to convert to. So what they're converting from, and then what they're converting to. Unfortunately, I didn't quite word that correctly in the right line. But again, it's just the same algorithm, taking out the spaces, capital letters. And after we get that, we put user input 2 equals new text 2, which is just, going through all of the stuff we just mentioned. What's this bit? Console, please enter the amount of user input 1. So then we're asking the player how many of that unit that they wanted to convert from, how many of that unit they actually have and want to convert to the new unit of measurement. So we pop this into a string, which is a double, just so if they have a really small decimal number, we can hold that number and actually convert that as well. And we try to pass it in. Obviously, if they use a letter for some reason, that won't work, and it will ask them to do it again, I believe. So while user amount equals 0, console.writeLine, you did not input a correct value. So obviously we initialize it to 0 to begin with, to allow it to always equal 0 if it doesn't pass in. So say they put in 27 full stop E, wouldn't be able to convert that to a double, because doubles only contain numbers and can contain full stops, obviously for decimal places, but it wouldn't be able to put in the E character, and so would not be able to pass it. So we would then ask the user to try again. As the user amount still equals 0, it will continually go through that loop until the user decides to put in a relevant value that will actually pass into the double value variable. Sorry. We then initialize a converted amount to 0. We check for the user input 1 and the user input 2. Or sorry, we initialize the string values to equal user input 1 and user input 2, and then the opposite way around. So this is to allow the program to check the data that it's taken from the sheet and find out where the actual lines are. So if we go back to the sheet, actually, we can show you. If we have obviously ounce and gram, if the user put in ounce and then gram, we would know that we need to take the amount of ounces and divide by by 28 to get the amount of grams that would show the actual conversion, and allow the user to know how many ounces are in so many grams, or vice versa. Obviously, if it was the other way around, where they put in grams first and they wanted to convert to ounces, it would divide by 28. This is a bit later on in the program. We have a double variable number, and I can't quite remember what that's for. So anyway, we got the loop to check for a match between the conversion the user wants to do and the conversions that's stored in the program, and we go through this. The last string array that we created, split by each space, because that's it's got spaces in between each word, so we know we have something to split by to allow us to get each word. And we get separated 0 and separated 1, so we get the string from line, string numbers. So this allows us to get both. Oh, sorry, in fact, I only had a space in between the number and the words, so that's why we didn't need a space here, which is already checking for no space. That'll be why. Number equals double dot parse string numbers. Obviously trying to pass in the string variable into a double. Obviously, if it doesn't quite work for whatever reason, it won't be able to quite do it. It won't throw in it won't cause the program to melt down and start crashing people's computers. It's a bit more user friendly that way. Even though it won't actually work at the end result, it won't cause the computer to crash. So then we ask whether check1 is equal to string from line, or whether check2 is equal to string from line. And as we can see, we know if check1 is equal to string from line, the converted amount is user amount times the number, and if not, if it's check2, user amount divided by number. This allows us to get the actual conversion, as whether it depends on how they put in the actual things, because we can see it's always there's always 28 grams in an ounce. There's always 16 ounces in a pound, and it always continues to be this layout, which was really what allowed me to do this properly. If it was a bit of a humble jumble of variables, could be wherever, or values rather, it wouldn't really work so well. And I believe there's not even really a program that would be able to do that unless it already knew what the conversions were, and if so, there would be no point reading in a conversion. Alright, sorry about that, my wireless headset just died. Lovely pieces of technology we have. And then if there's any other bit that doesn't allow us to, if the string from line does not equal either of those for whatever reason, we don't do anything. The reason we have match found equals true, so next we can say if match is found, or if the match isn't found, we can say the units of the measurement that you put in have not been recorded to this program. Please reinitialize the program. Allows the user to go through again and hopefully read in either a different sheet that they've been given, whether they loaded in the wrong sheet, or otherwise try a different conversion. I realise now, looking at this, I didn't actually have to have a match found boolean. Could have just put this line of code inside of the else, and then a little bit outside of it saying, you know, the rest of it basically. Else, you know, right, we have converted your input, so now we have the converted thing telling the user their actual conversion, and telling them if they would like to exit the program, please enter a 1, otherwise enter any other value to reinitialize, and then again reading in what the user puts, trying to convert, taking that, putting it in user check, then getting a number check variable with an int variable type, and trying to pass in what the user has put in. We then see if it's a 1 or a 0, and if it's a 1, the user wants to exit, and will come out of the loop at the top and allow the user to exit the program. Otherwise, if it's a 0, they obviously want another conversion or a slight mishap maybe. So now we can see this working. So we can see here, if we take a quick look back at the notepad, we can see that the results from the file are indeed ounce gram 28, pound ounce 16, pound kilogram 054, and so on. So we've got that, and we want to convert this time maybe kilograms. So if I put in kilogram, and then we want to convert to pound or to pounds, and then we want to enter in our amount of kilograms. Let's say we have 10, just to be nice and even. We can easily check what the result is. So now we've got the feedback. 10 kilograms is equal to 22.02 so on pounds, and I believe I didn't want to use that one to easily find out. Let me just try this again with inches and centimeters, and we'll easily be able to see what the conversion is. So inch, centimeter, the amount of inches, we've got 10, and so we should get, yep, 25 centimeters. We can see that one works very well. Couldn't quite see so well with the pounds to kilograms. That was a bad example on my part. Trying to times by 0.454 in your head is not a great way to do maths. And now we obviously get the program asking us if we'd like to stay and do another one, or whether we'd like to exit. And so I'll just pop in a 1, press enter, and we're back out of the program. And so I hope you enjoyed having a quick look at one of my modules for the first year. Thank you for watching.